Center of mass is another concept we're introducing here that is, it's just calculating where the center of mass of a system of objects is. And this is important in aviation, and especially in small planes where you'll have to make people move around sometimes to adjust where the center of mass of the passengers are in a plane, because you don't want everybody sitting on, one side of a small plane, because then you're going to spend the whole flight trying to correct for that. So, um, and really it comes down to where is the X center of mass, where's the Y center of mass, where's the Z center of mass. Usually we're only worried about two of these, like X and Y, not all three. Um, but you're just adding up the X position times mass that's at that position. And that's all you're doing. You're just adding up all of those. That's what this sigma, this Greek character should have explained earlier. That's a capital sigma, and this means sum. We're summing. Sorry, got to explain that earlier. So that is summing. So we're going to sum all of the masses times their position. And then we're going to divide by the sum of all the masses. And so don't let this notation confuse you. Just start thinking of x1 m1 plus x2 plus m2 plus x3 m3 plus x4 m4, all divided by m1 plus m2 plus m3 plus m4. And let's go back to our table example. What does it mean in our table example? If I could get, oh, I've got to stop drawing. Okay, in our table example, what it means is, let me just make more of these. Copy, paste. Okay, and I don't even need a table. Let me move the table. Well, let me leave. Yeah, I'm gonna move the table out of the way. Table, go, go. Okay, so what does it mean in our table example? What it means is we've got some XY plane. And we're going to make it simple and assume all of these are just sitting on the XY plane. And so this set of books have some position, let's call that X2 and Y5. And let's call this X5 and Y1. And this we're going to call X8 and Y4. So how do you do this? This is X, and that's Y. Well, in X, it's just going to be, we're going to call this M1, this M2, and this M3. The X center of mass, I write so well with the mouse, is just M1, whatever that mass is, times 2, its X position, plus M2 times 5, plus M3 times 8. And all of that is going to end up divided by M1 plus M2. And I'm running out of room, plus M3, right? And that's going to give you the X center of mass. For the Y center of mass, it's the same equation, except this 2 is now that 5, this 5 is now that 1, and this 8 is now that 4. So the Y center of mass is M15 plus M21 plus M34, all divided by M1 plus M2 plus M3. And that's all getting the center of mass is. So you get the X center of mass, you get the Y center of mass. If you've got a distribution in Z, you can get the Z center of mass. And that's all great, because that tells us, what does that tell us? That is any force that goes through, that's along a line with the center of mass, acting on the object, does not cause rotation and simply causes translational motion. And that's it for center of mass.